Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 5. Derivatives as pure symbols. Remember the language we are learning. There is one field, phi, the holophase. One continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We are in Episode 8, the pure abstract language. In parts 1 through 4, we established what phi is in its essence: a pure mathematical creature, a silent potential, with shift symmetry that makes only differences matter, and living on a circle rather than a line. We have understood the stage, the background structure in which the holophase language exists and moves. Today, we begin Book 8.2, the abstract alphabet. We move from the stage to the players. We meet the letters of this language, the derivatives of phi. But here is the crucial shift for this episode. In this abstract exploration, derivatives are pure symbols. They are not yet frequency, not yet wavelength, not yet acceleration, not yet force, not yet anything physical. They are formal answers to structured questions about how phi changes. They are the letters of a code that has not yet been spoken by any particular universe. If episode 7 was about learning to read reality as a book written in phase, episode 8 is about stepping into the library before any books are printed and studying the alphabet itself. In part 5, we are going to stand in front of the shelf where all the basic change symbols live and learn to recognize them as pure letters, long before we attach them to any physical phenomena. Let us begin with an image. Imagine that you and I are walking through an ancient, silent archive. The shelves are made of dark wood, polished by centuries of hands. On one of the tables, we find a beautifully crafted box. Inside the box, there is a collection of carved wooden tiles. Each tile has a mark on it, a symbol, but we do not yet know the language it belongs to. We do not know how the symbols sound. We do not know if they represent objects or actions or abstract ideas. We do not even know which direction they are supposed to be read. But we can see that there is structure. Some symbols are simple, some are more complex, made of repeated pieces. Some seem like variations of others. The derivatives of phi in this episode are exactly like those tiles. The time derivative of phi is one tile. The spatial gradient of phi is another tile. The second derivative of phi with respect to time is a more elaborate tile. A mixed derivative, which asks how time change varies in space, is a tile with multiple layers. Right now, in this pure abstract language, each of these is just a symbol in a box. We are not yet saying this one is frequency, or that one is curvature, or this one is acceleration. We are simply saying, here is a structured symbol that answers a particular kind of change question. So what is that fundamental question? At the deepest level, every derivative, no matter how complicated, is an answer to one core inquiry. How does phi change? You can almost think of the holophase language as built on a single word, change, repeated in more and more refined ways. Every derivative is a new way of asking that same word to speak with more detail. The first derivatives ask the most direct questions. How does phi change in time? How does phi change in space? How does phi change when I move through both time and space together along some path? These first questions give us the basic letters that will later be called omega, k, d phi, and v. But in our current abstract setting, we keep them nameless for a moment and just call them time change of phi, space change of phi, and overall change of phi. The second derivatives ask a deeper question. How does that change itself change? If the time derivative tells us how phi moves around the circle as time flows, the second time derivative asks if that movement is steady, speeding up, or slowing down. If the spatial gradient tells us how phi changes from one location to another, the second spatial derivative asks whether that change is flattening out or sharpening into a peak. Mixed second derivatives ask how the time change varies from place to place, or how the spatial change evolves as time passes. The third derivatives repeat the same pattern at an even finer level. How does the change of change itself change? And the fourth derivatives do the same, and so on, layer after layer, climbing into an infinite tower of ever finer questions. At each level, we are still only talking about change, but at each level, we are looking more closely at how that change behaves. You can compare this to talking about a journey. First, you might say, I am walking north. That is like describing your velocity, the first derivative of your position. Then you might say, I am speeding up. That is like acceleration, the second derivative. Then you might say, I felt a sudden jolt as the car lurched forward when the driver pressed the pedal. That feeling of a sudden change in acceleration is like the third derivative, sometimes called jerk. If you keep going, you get snap, crackle, and pop, humorous names used by some physicists for higher derivatives. The names do not matter. What matters is that all of these are simply deeper layers of how is this changing? In the Holophase language, derivatives of phi are the complete catalog of such how questions. They are the structured ways phi has to talk about its own variation. They are not something separate from phi. They are phi looking at itself from many different angles and reporting what it finds. In the language metaphor, that makes derivatives the alphabet. Each derivative is a letter, or in some cases, a cluster of letters that we can use to build words and sentences about how phi behaves. But there is a crucial difference between this alphabet and human alphabets. Our ordinary letters like A, B, and C are arbitrary. There is no deep reason why the shape we call A should have the sound we call A. We just agree to that mapping. The derivative alphabet of phi is not arbitrary. Its symbols are generated by a single, meaningful operation. Take the change with respect to something. Each time you apply that operation, you move one step up the ladder, from phi to its first derivatives, from first to second, from second to third. The symbols know their own place in the hierarchy. A first derivative is always a first question about change. A second derivative is always a question about the behavior of the first answer. A third derivative is always a question about the behavior of the second answer. In this sense, the alphabet is not a bag of unrelated marks, but a living tree of related symbols. Now let us weave this back into the three-dimensional echoes that are at the heart of the holophase view: time, space, and motion. From the time perspective, derivatives that involve time tell us about rhythm, pacing, and temporal structure. The time derivative of phi measures how quickly phi moves around its circular value space as time passes. The second time derivative measures whether that motion is steady or changing. Higher time derivatives capture more subtle features of the timing. Without attaching any physical labels yet, we can already say that the time branch of the derivative tree is the part of the alphabet that will eventually speak about beats, frequencies, cycles, growth and decay rates, and all temporal patterns. From the space perspective, derivatives that involve space tell us about shape, texture, and spatial structure. The spatial gradient of phi measures how phi changes from here to there. The second spatial derivative measures how that change itself bends. Higher spatial derivatives capture ever finer details of the spatial pattern. Without mentioning fields or forces yet, we can say that the space branch of the derivative tree is the part of the alphabet that will eventually speak about slopes, peaks, valleys, edges, and the geometry of patterns in space. From the motion perspective, derivatives that mix time and space link the two. They tell us how patterns in phi move, propagate, and deform as time passes. Mixed derivatives like time change of the spatial gradient ask how shape evolves. Mixed derivatives like space change of the time derivative ask how tempo varies across space. This mixed branch of the derivative tree is the alphabet that will eventually speak about waves, flows, transport, and trajectories. Notice how all of this keeps the tri-unity of time, space, and motion at the center. We are not building three disconnected alphabets. We are using the same operation, take the change, along different directions in the same underlying field. The unity lies in phi. The diversity lies in the directions in which we ask our change questions. Where then does this derivative alphabet sit in the master tree we have been climbing since earlier episodes? It is, quite literally, the first visible branching above the root. The root of the master tree is phi itself, the undifferentiated field of potential. The moment we allow ourselves to ask, how does phi change? The root sprouts branches. Those branches are the first derivatives. From those branches grow more branches, the second derivatives. From those grow further branches, and so on, forming the infinite canopy of the derivative hierarchy. You can think of phi as the trunk, derivatives as the branches, and higher derivatives as the twigs, then the finest twigs, and finally the tiny buds at the tips. But do not forget that the wood in every branch and twig is still the same substance as the trunk. In the same way, every derivative is still phi, just viewed through a different lens of change. Now let us ask an important scientific question. Are derivatives enough? Is this alphabet complete? If we are going to build an entire language of reality from change questions, we need to know that we are not missing some essential class of symbol. In many areas of mathematics and physics, there is a powerful idea called the jet of a function. The jet at a point is the list of all derivatives of that function at that point, from first to second to third, all the way up. In principle, if a function is smooth enough, knowing all its derivatives at a point allows you to reconstruct its behavior near that point. This is the intuition behind Taylor series. You write a function as a sum of terms built from its derivatives at a single point, and those terms tell you how it behaves nearby. In our language, the infinite jet of phi at a point is like having a complete local dictionary of how phi can behave near that point. The values of phi and all its derivatives together contain, in principle, all the local information you could ever want. The derivative alphabet, stacked in all its orders, becomes a complete descriptive toolkit for local patterns. Of course, the world is more complicated than a single tidy theorem. There are functions that are continuous but not differentiable, patterns that are rough or fractal at every scale. There are non-local phenomena, where what happens at one place depends on distant regions, not just on local derivatives. The Holophase language is honest about this. We present derivatives as our primary alphabet, but we also keep our eyes open for situations where change questions alone might not be enough. If later we discover that certain patterns simply refuse to be described in terms of phi and its derivatives, even in principle, then we will know we must extend or refine the alphabet. This brings us to falsifiability. How would we know that the derivative alphabet is not sufficient? One way would be if we ran into a phenomenon that demands a symbol which cannot be written as some derivative of phi. Another way would be if we found that even knowing all derivatives of phi at all points in some region was not enough to reconstruct the behavior of phi there. A third way would be if essential physical effects, turned out to rely on global, non-local features that never show up in any finite stack of derivatives. In each case, the Holophase program would have to adapt. If you want to see how these completeness questions look in full mathematical detail, you can search for Holophase on Zenodo. There, you will find the scientific papers that this audio journey is built on, including formal discussions of jets, locality, and the conditions under which derivatives capture everything that matters. For now, for the sake of our conceptual journey, we embrace derivatives as our working alphabet, and we practice using them, not by writing equations, but by training our way of seeing. You can begin doing this immediately in your everyday life. The next time you look at a graph of something changing over time, the temperature across a week, the number of visitors to a website, the value of a currency, do not just look at the line. Ask derivative questions. Is the line going up or down? That is the first derivative. Is it bending upwards or downwards? That is the second derivative. Is that bending becoming more or less intense? That is the third derivative. When you listen to someone speaking, you can do the same. The actual words are like the values of phi. The tone of voice, rising or falling, is like the first derivative. The rate at which the tone rises or falls is like the second derivative. The sudden shifts in emotional intensity are like the third derivative. Without ever writing a formula, you are already thinking in the derivative alphabet. When you drive a car, you feel derivatives with your whole body. Your position on the road is phi. Your speed is the first derivative. Your acceleration, what pushes you into the seat or throws you forward, is the second derivative. The jerk you feel when acceleration changes suddenly is the third derivative. Your body is an excellent derivative detector. And when you look at the landscape, you see derivatives written into the shape of the earth. The slope of a hill is the first derivative of height. The way that slope changes, becoming steeper or flattening out, is the second derivative. The changing of that change gives the landscape its unique character, its gentle rolling or its dramatic cliffs. In all of these examples, notice something important. You are not introducing new substances when you talk about derivatives. You are not saying there is one thing called position, another thing called velocity, another thing called acceleration, as if they were separate materials. You are simply describing different aspects of how one thing changes. In the Holophase perspective, the same is true. There is only phi. Derivatives are how phi talks about its own unfolding through time, space, and motion. Before we finish, I want to slow down even more and give you a few extra pictures that will make this abstract idea of derivatives as pure symbols feel natural, even friendly in your everyday experience. Imagine you're standing by the sea, watching waves roll toward the shore. If phi were the hidden face field underneath those waves, then the surface you see is one particular way phi is expressing itself. The height of the water at your feet is like the value of phi at one point. But your body notices more than just the height. You feel whether the water is currently rising or falling against your legs. That is a first derivative feeling. You also feel whether each new wave is coming in more strongly or more gently than the last. That is a second derivative feeling. And if a storm is building far away, you might sense that not only are the waves getting stronger, but the rate at which they strengthen is itself increasing. That is a third derivative sensation. You're not doing calculus on the beach, yet your nervous system is tracking the story of change, layer by layer. Or think of sitting in a busy cafe. The volume of conversation rises and falls. At first, you just notice how loud it is right now. That is like phi. Then you notice whether it is getting louder or quieter, as more people come in or leave. That is like the first derivative. After a while, you may feel that the pace of change itself is changing. Sometimes the room suddenly becomes noisy very quickly. Sometimes it quiets down slowly. This intuitive sense of how fast the loudness is changing is like listening to a second derivative. You might even feel sudden jolts in the atmosphere when a group arrives laughing loudly or when a heated argument abruptly stops. Those jolts are like third derivatives. The cafe is a living classroom in the alphabet of change. We can also look inside ourselves. Consider your own breathing. At any moment, your lungs have a certain volume of air. That is like the value of phi. As you breathe in or out, that volume is increasing or decreasing. That rate of change is like a first derivative. When you speed up your breathing because you are climbing stairs or feeling anxious, the rate of change of your breathing rate itself is like a second derivative. And when your breath shifts suddenly from shallow and fast to deep and slow, you experience something like a third derivative, a change in how the change of your breathing is changing. Even without equations, your lived experience is rich with these layers. These examples are not physics lessons, they are analogies. I am not saying the sea, the cafe, or your lungs are literally computing derivatives of a hidden phi function. I am saying that your intuition already knows how to track change at several levels. The holophase language takes that intuitive skill and formalizes it in a precise, unified way through derivatives of phi. When we speak of derivatives as pure symbols, we are giving careful names to abilities your nervous system already practices every day. Another useful picture is to think of stories rather than numbers. Imagine reading a novel. The state of the main character at each chapter is like the value of phi. The first derivative is like asking, is this character's life getting better or worse right now? The second derivative is like asking, is it getting better faster or is the improvement slowing down? Is the tragedy deepening more quickly or is there a hint of relief? The third derivative is like sensing, is the change of mood itself about to flip? Is this the point in the story where everything turns around? A skilled reader pays attention to all of these layers without ever drawing a graph. In the same way, the derivative alphabet allows a skilled reader of reality to feel not just what is happening, but how the happening is evolving. Because this episode is about the pure abstract language, it is important to emphasize one more time that, at this stage, derivatives do not yet belong to any particular science. The same derivative symbol could later describe how light waves change, how a heart beats, how a market rises and falls, or how a pattern of brain activity shifts during a thought. The power of the abstract alphabet is that it is reusable. Once you understand the pattern, first change, second change, third change, you can carry that pattern into any domain you like. The alphabet stays the same even when the stories you write with it are completely different. This also shows us something about the unity of knowledge. In school, subjects are often split apart. Physics here, biology there, economics somewhere else, psychology in a different corridor. It can feel as if each discipline has its own isolated language. The holophase view suggests that underneath these differences, there is a shared alphabet of change. A curve on a physics graph, a growth chart in medicine, a trend line in economics, and a learning curve in education are all, at their core, shapes of phi-like behavior. They can all be described by asking derivative questions. When you learn this alphabet once, you gain a key that unlocks understanding across many apparently separate fields. There is a quiet humility hidden in this idea. It says that nature does not need a different fundamental language for each new phenomenon. Instead, one field and its derivatives are enough to describe everything from the motion of galaxies to the flicker of a thought. Whether or not the holophase program turns out to be the final word about reality, the discipline of looking for one underlying alphabet is itself a powerful way to organize our understanding. It pushes us to ask again and again, can this pattern too be written as a story of change in phi? Finally, I want to reassure you about something that might be sitting at the back of your mind. You might be thinking, this sounds like a lot of mathematics. I'm not a mathematician. Will I be left behind? My answer is you will not. The purpose of this audio journey is not to turn you into a calculator. It is to turn you into a listener who can hear the language of change. You do not need to manipulate formulas to benefit from this. You only need to cultivate curiosity about how things change and patience to follow the layers of that change. If you can notice whether something is increasing or decreasing, you already understand the spirit of a first derivative. If you can notice whether that increase is speeding up or slowing down, you already understand the spirit of a second derivative. If you can feel when a situation is about to flip dramatically, you already have an instinct for higher derivatives. The formal symbols of the Holophase alphabet are just a precise way to honor and extend these natural human abilities. With that reassurance, we can now return gently to our main line. We set out, in this part, to see derivatives as pure symbols in an abstract alphabet. Along the way, we have met them as carved blocks in an unknown script, as layers of questions about the journey, as branches growing from a single trunk, and as patterns of change in waves, cafes, breaths, stories, and lives. All of these pictures point to one insight. Derivatives are not exotic. They are simply a disciplined way of talking about change that reality is showing you everywhere. As we close this part, let us zoom out and remember where we are in the larger climb. We are still in Episode 8, the episode where we study the pure abstract language of reality before it prints any particular universe. We have understood phi as a mathematical creature, as pure potential, as having shift symmetry, and as living on a circle. Now, in part 5, we have met the derivative alphabet, the infinite family of pure symbols that answer the question, how does phi change, in every possible way and along every possible direction. We are still near the base of the master tree of language, but the structure is becoming clearer. From the root phi, branches grow in the form of derivatives. Those branches split into time, space, and motion echoes. Higher and higher derivatives create finer and finer articulations of change. All of this is still just one field and its derivatives, one language and its alphabet. Remember, everything we have talked about is still just one field, phi, and its infinite tower of derivatives, the single language the universe uses to write every story. In this episode, we have climbed further into the master tree of that language, from the root and the soil to the first major branching of its alphabet. With this part, we have walked one more branch, and we can already see how rich the eventual canopy will be. In the next part, we will explore how this alphabet organizes itself into a hierarchy, how first derivatives, second derivatives, and higher derivatives form a structured system. We will begin to recognize familiar friends like omega and k, and v as particular letters in this general alphabet, still in their abstract roles, not yet tied to any specific experimental setup. For now, as you go about your day, I invite you to try a simple practice. Whenever you notice something changing, a sound fading, a cloud forming, a mood shifting, traffic speeding up or slowing down, quietly ask yourself, what is the first derivative here? What is the second? What is the third? You do not need numbers, you just need the questions. Each time you ask them, you are training your mind to think in the derivative alphabet of phi. The alphabet exists. The stories it can tell are infinite. Together, we are learning to read. Salam, and peace be upon you.